All right, brilliant. Welcome everybody. Welcome to the fifth ISPAR conference for the Institute for Sport and Physical Activity Research. I'm delighted to welcome you as Director of ISPAR. My name is Professor Angel Chater, and today our focus is on getting back on track and moving forward from COVID-19 with sports performance, physical activity, health and well-being. It's lovely to be able to welcome you all today, and especially, during these times online. Usually we'd be welcoming you in our big glass gateway building on the Bedford campus, and it's been quite nice that we can extend our invitation to people who wouldn't normally be able to join us in Bedford. So welcome. Please bear with us. This is the first time we've done a virtual conference, so I'm hoping it'll go okay, but who knows, we might have some hiccups, so please do bear with us. You've all entered the room on mute. Please do keep yourself on mute just so that the speakers don't get distracted. And we are recording this and it's being live streamed. So if you wanted to keep your videos on or off, completely up to you, but just for you to know that we are recording. So we have a fantastic group of speakers today, and I just want to give you a brief background of the Research Centre, the Research Institute, and our three research centres. So we have the Centre for Physical Education, Sport and Human Movement, which is led by Dr. Joanne Hill, the Centre for Health, Wellbeing and Behaviour Change, which I lead, and the Centre for Physical Activity and Sports Performance, which is led by Dr. Ian Fletcher. And within our research centres of ISPAR, we have a number of different special interest groups that look at things like sport and pedagogy, behaviour change, intervention development, managing long-term conditions and sport performance and biomechanics. And you're going to hear from a number of our experts over the next 3 days. We also have a practice centre for the Institute, the Human Performance Centre, and we offer a range of health, fitness and wellbeing services that are aimed at optimising your overall wellbeing. These include environmental testing, VO-Max testing, anthropology testing, behaviour change support and so on. So if you're interested, please do get involved and contact us at the Human Performance Centre. So today is about celebrating ISPAR research. Novel research sits at the outer layer of human knowledge. It pushes the boundaries of current science. And our focus within ISPAR is around creating research with impact. So today is about showcasing the talent we have within ISPAR, and we encourage you to help us to have that impact by sharing our research, talking about it on social media, and using our Twitter handles and our hashtag ISPAR20. We also embrace an active campus. If you were on campus in our Gateway building, you'd see that we have sit-stand desks. We would encourage you to be standing and moving around in our conference. We have treadmill desks in our student areas, and we encourage standing meetings. So wherever you're watching from today, we encourage you to stand and move around during presentations and to sit less. The agenda is today being brought to you by the Centre for Health, Wellbeing and Behaviour Change, which is my centre, looking at physical activity, behaviour change and the benefit of long-term conditions and psychological wellbeing. Tomorrow, Dr. Joanne Hill will bring to you from the Centre for Physical Education, Sport and Human Movement, looking at getting back on track through distance physical activity, physical education, pedagogy, relationships and a sense of belonging. And on Friday, Dr. Ian Fletcher will bring to you from the Centre for Physical Activity and Sports Performance, getting back on track, the lessons learned and the plans for sports return to a new normal. So there's still time to sign up for tomorrow and Friday with the Eventbrite link you used for today. So to focus on our ISPAR Centre for Health, Wellbeing and Behaviour Change today, this research centre focuses on the salient importance in public health of how we can optimise health promotion, disease prevention and treatment efforts to enhance health and wellbeing of the nation. And today we're going to hear from consultant oncologist, Professor Robert Thomas, who's based at the Bedford Hospital, who is a leading expert in moving medicine, particularly around physical activity and chronic illness. We'll then hear from some people who've attended the University of Bedfordshire Exercise Clinic, and then some of our PhD students looking at the impact of reducing sedentary behaviour in different populations. Abby and Kamalesh will talk about cardiac rehab in South Asian populations, and Marsha will talk about work we've been doing with Bedfordshire Police. We'll then have a short break and we'll come back to look at physical activity trials enhancing behaviour, weight management and glycemic control, and how to overcome challenges during COVID-19, brought to us by Emma Wells, who's one of our graduates now based at the MRC Epidemiology Unit at University of Cambridge. Then Julia Frewer will talk about breakfast consumption, physical activity and glycemic control in adolescent girls. And Jane Williams, another of our PhD students, will talk about what role physical activity plays in the lives of young people following the death of a parent. And the session will conclude with Bert Clemmer, another one of our graduates, now based at the Mental Health and Emotional Wellbeing Service for Children and Young People at CHUMS, who will talk about supporting young people's psychological wellbeing through physical activity, and again, considerations made during COVID-19. So I just want to take the opportunity to thank our funders. We are funded from a number of different organisations, from research councils to charities to active partnerships, local and national authorities, the Police and Crime Commissioning Group, active partnerships and FIFA. So huge thank you to everyone who's invested in ISPAR and who continue to invest in ISPAR. And a final thanks to the team in ISPAR. We've got a fantastic group of researchers, both through the ISPAR staff, who are the group on the left, and our ISPAR postgraduate students, who are the group on the right. They do a phenomenal amount of work in various novel areas of research, and you're going to hear a lot from them over the next 3 days. So without further ado, it leaves me to introduce our first speaker, Professor Robert Thomas. And Robert, as I said, is a consultant oncologist at Bedford Hospital, looking at moving medicine, physical activity and chronic illness. So Rob, over to you.
Thanks, Angel. Can you hear me?
We can hear you. We just need to see your screen.
Okay, I will share screen right now. Can you see my slides?
We can, Rob, thank you.
Okay, do you want me to start?
Go for it.
Lovely. Well, first of all, thank you for the introduction. And can I just say, I've been really pleased to be associated with the University of Bedfordshire over the last couple of years. And I'm really excited that we're starting some, one major study, which is already about to start, the GAP4, which is an international study, which has been struggling for numbers around the world. But I think we're going to come in as the saviours of that study and recruit very well over the next 18 months. It's just COVID has set us back, and I'm really excited to be starting some other new studies. But anyway, I just wanted to say that to the public, and I'll crack on with the talk now. So as you said, I treat breast cancer, bowel cancer and prostate cancer, a bit of bladder, with mainstream drugs, biological agents. But I've had an interest in patient empowerment and sort of lifestyle strategies for the last 20 years, and we have a very strong clinical bias to that. And I'll share some of that data with you today, particularly relevant to physical activity. So fortunately, the chance of being cured from cancer is going up tremendously, and the chance of living with active disease for longer is also been greatly extended, mainly due to developments in drugs. For example, the chance of surviving metastatic prostate cancer is probably up to about 11 or 12 years now. It used to be just 2 years. But the consequence of these extra drugs and these extra things patients have to endure is a lot of long-term side effects. We already have the traditional side effects of chemotherapy, such as hair loss, fatigue, nail changes, hand-foot syndrome, etc. Hormones, where people are on now for 10 years or more, as opposed previously for 5 years. We're getting problems with osteoporosis, abdominal obesity, sexual functions, hot flushes. which is preventing people exercising and getting on with their life. But more recently, we're using, at least half the patients are on biological treatments, such as monoclonal antibodies or tyrosine kinase inhibitors, which have a whole host of degenerative side effects, such as things like increasing cholesterol levels, reducing thyroid function, increasing your blood pressure, having damaging effects on the heart, pneumonitis, cognitive function, increased risk of dementia, and of course increased risk of infections such as COVID. So oncologists are having to rely on their general physician training to manage these conditions, most of which actually, as you can already might have deduced, are lifestyle related. So if we can incorporate a healthy living program in oncology, it's going to do a lot to improve people's quality of life over the years. So how can exercise specifically help patients? Well, we know that it could help prevent you getting cancer in the first place. We know it could improve the response to treatments. It will reduce the risks, such as develop infections or thromboembolism, and it can lower the relapse rate. And as I just said, it can reduce the risk of this secondary degenerative, chronic degenerative state which is occurring. So where did the evidence come first? Well, going back in time, this was one of the pivotal papers by Thune, which looked at a prospective cohort of 25,000 women. And they worked out that women who were able to exercise over 3 or 4 hours a week had a reduced risk of developing breast cancer in the first place. So that's quite reassuring. And that's, physical activity in the workplace or in, in recreational times. But then talking about relapse, the first time we realized it could help relapse rates or cure rates was a paper from Giles from Australia, which looked at a whole cohort of people who had gone through the trauma of bowel cancer and chemotherapy. And then further down the line, they looked at which patients exercised and which didn't. And there was a 14% difference in the relapse rate, bearing in mind that chemotherapy will give you about an 8% difference in relapse rate. Chemotherapy was a very significant improver of survival. At the end of this talk, you can have a copy of it. I've listed the 45 trials which show for other tumor types such as prostate, breast, bowel, as I've just said, showing that if you can get up to about 3 hours of moderate physical activity where you get hot and sweaty, you're actually doing something rather than walking around the park looking at the petunias, you actually have about a 30% reduction in relapse rate. So it's one of the strongest things a patient can do to help themselves to stop their cancer coming back. So why does exercise have these anti-cancer properties? Well, there's lots of reasons, and I split them up into indirect and direct. The indirect would be increasing vitamin D because you're exercising outside, losing weight, and improving psychological morbidity. In terms of weight reduction, people argue that it doesn't really cause weight reduction. I would dispute that. There are a number of large studies, including the energy study, showing that if you persist with a good supervised exercise program, you eventually do get about a 10% reduction in weight. So it's not massive, but it is statistically significant. But it has, it's not an overnight cure. These programs are long-term. The main worry we have in patients with cancer, if they have sarcopenic obesity, where not only they're big, but they have small muscles. And we know the muscle to fat ratio means they're very unlikely to tolerate chemotherapy. They're more likely to have complications and more likely to progress and relapse. They're also more likely to get COVID because that proportion of muscle to fat ratio reduces immunity and makes them susceptible to COVID during their illness. And we've already given them drugs to lower their immunity as well. How else does it affect you? Well, we know that if you exercise regularly, you change the health of your gut. It improves the healthy bacteria, so it can improve gut health. exercise itself has a direct anti-inflammatory component. We know if you went out and played a game of rugby or something, had lots of bruises, your inflammatory markers would go up. But in the long term, there are studies such as one here from Martinez, which actually took rectal biopsies in people who exercise, shows that intramucosal prostaglandin levels reduce after regular exercise. And we know that chronic inflammation or excess inflammation is a driver of cancer. So the combination of reduced inflammation and improved gut health is very important in oncology. This is a slide just summarizing there are other factors such as smoking, sugary foods, can increase these things. We know that exercise, eating nuts and eating lots of polyphenol rich foods reduces inflammation, not only for cancer, but for all these other chronic diseases I've mentioned, which is now an issue in oncology, such as diabetes, high cholesterol, dementia, neurodegenerative disorders. I'll just list, in 20 minutes, we can't go through all the biochemical changes. There's probably 180 which happen, but just list through. Exercise lowers insulin-like growth factor, which we know high insulin-like growth factor is a driver of cancer cells, such as we know it reduces excess estrogen levels. Now, this is not just by reducing obesity rates. Estrogen levels drop before you start losing weight. So, the picture of that sarcopenic obesity person, if you can increase muscle mass, even if you're not reducing weight, you are getting a significant benefit and your excess estrogen levels are dropping. This is a nice study to show that 180 genes change their expression after exercise. And in general, the genes which protect you, the tumor suppressor genes, expression is increased, and the tumor promoting genes are decreased, particularly things like BRCA1 and BRCA2. And there are other chemicals like vasoactive intestinal protein, leptin, irisin, they all change, and now more recently mTOR expression all change, but again, we won't go into that. If anyone wants a summary, we wrote a very nice article in the British Journal of Sports Medicine with Stacey Kenfield from Southern California, which summarized these 180 biochemical changes which occurs after exercise. I would like to refer you to that paper. So in terms of other benefits of exercise, we know that if you particularly have a supervised exercise program, this was a meta-analysis of 33 randomized trials, show it does significantly reduce your fatigue, improves your mood, improves muscle power and exercise capacity. So there's no doubt it does reduce toxicity. I've already mentioned it reduces thromboembolism risk, which is a big problem in oncology. Also osteoporosis. Again, we're making women and men prematurely postmenopausal. We're giving them drugs like aromatase inhibitors, which damages bone density. You end up having an increased risk of fracture, being admitted to Bedford Hospital, catching a superbug, and that's the end of it. So you really got to make sure people protect their bones. And we know that exercise, in addition to things like bisphosphonates, are very beneficial. So we should be putting any patient we've made postmenopausal or starting on these drugs should be put in an exercise program. And when we advise exercise, of course, we need to ask experts to help us, like yourselves. There's no point just saying to a patient, exercise, because if they're overweight, they should be doing more exercise reduction type things like cycling, swimming, or running. But cycling and swimming will do nothing for bone density. So they need to go into specific exercise to help bone density if that's a problem. So patients need to be individualized on their training regime, and that's why it's very important to refer to the program in Bedford University so they can do that. And also, it's not just about exercise, it's about combining with diet. We know, for example, osteoporosis, you should be increasing calcium in your food, vitamin K2, and plant-based proteins. Coming on to arthritis, 55% of our patients develop arthritis after our treatment for various reasons, usually the drugs we're giving them, and that is a barrier to exercise. So, we're saying to people, do exercise, and they say, I can't because you've caused arthritis. So we need to address arthritis and tackle it at its core. How do we do that? Well, we know there's plenty of data to saying stretching, Pilates, or good exercise programs will help arthritis. Many people are turning to over-the-counter supplements for this. In fact, this is a study we presented in Australia, shows that 64% of our patients are taking supplements to try and help well, either for a reason we don't know or to try and help a symptom such as arthritis. This Arthritis Research UK produced a nice document saying, well, what supplements could help arthritis. Unfortunately, the ones which people tend to take, fish oils, chondroitin, glucosamine, the evidence isn't actually particularly strong. Where the evidence is much stronger is these what we call polyphenol-rich foods. Polyphenols are the nutrients within foods which have previously been undervalued. They have enormous biochemical influence on our body, and you find these in foods which look good, taste good, and smell good. So there's an additional to your diet. Things like turmeric, tea, broccoli, anything, a chili, rosehip, mushrooms, that sort of thing. And there's lots of evidence that these foods have a direct influence on cartilage thickening and inflammation. So they don't just help the pain, they help regeneration of cartilage. So they also, in terms of oncology, they also help cancer. This was a study we're publishing right now with Glasgow University, which we analysed 155,000 people over 12 years. And amongst other things, we asked them if they drank tea or not. And we're pleased to report that if you did drink tea, you had a lower risk of prostate cancer, which is contrary to a previous study which suggested not. And so we feel we've now can reassure tea drinkers they can enjoy their beverage with confidence. We know that this is not really a surprise, I suppose. We also looked at broccoli. And again, if you had on average, a small cup of broccoli a day, you had a 5% lower risk of any cancer. So, we know that these foods do have anti-cancer properties. I won't harp on about this study because I've presented it quite a few times before, but we were looking to see if we could boost patients' diets with a dietary supplement, a whole food supplement. And this was something we published in 2014, 15, I think, where we got a supplement containing green tea, broccoli, turmeric, and pomegranate. We randomized against placebo, and we were pleased to see a very significant reduction in PSA progression in men with prostate cancer. And then we then did a sub-study looking to see if that influenced underlying MRI changes, and it did. So we know that boosting the diet with these foods is very beneficial. Why do polyphenols have an anti-cancer property? Well, again, they help regulate the immune system by improving inflammatory response. So increases in inflammation when you need it, but decreasing it when you don't need it. So they're not direct antioxidants, anti-inflammatory. They can improve gut health because they're prebiotics and help the healthy gut bacteria. They reduce the absorption of sugar, reducing the glycemic index, and they have some direct anti-inflammatory, direct anti-cancer properties. They are not actually direct antioxidants, even though the press and everyone else refers to them as antioxidants. Antioxidants are your vitamin A and vitamin E and acetyl drugs. So they just encourage the formation of antioxidant enzymes when they are needed. Any good talk does look at the risks as well as the benefits. One of our oncologists, Shazina, I was going to show you a picture, went for a run, not accustomed to running, and fell into a ditch and broke both arms and had lots of bruises. So it can happen. So again, if you're not used to exercise, a supervised program has advantages. We know, of course, that if you start exercising without training or you over-exercise, you do actually increase the amount of free radicals in your body, because free radicals are a side product of energy production. When you exercise, however, you adapt to this by increasing your antioxidant enzyme formation. And that's why, again, it's important to do a graduated supervised scheme. It's also important that you then support your diet to encourage the changes which are required. So you make sure you get enough minerals and vitamins, and you take enough polyphenols, which help the improvement of antioxidant enzymes. And that's why, no doubt, you and your nutritionists are very keen on, blackberry picking and taking beetroot smoothies and all sorts of things like that, which encourage antioxidant enzyme formation, as well as containing nitrates, which also improve oxygenation. And what people get confused about, of course, is that they say, oh, antioxidants actually can reduce exercise performance and increase oxidative stress. But they are actually referring to direct antioxidants such as vitamin A and vitamin E, but the press very rarely differentiate the two. They just have numerous articles saying that supplements can cause cancer, etc. So basically, this is a little schematic we've drawn. The other thing polyphenols do is switch off the antioxidant enzymes when they're not needed. So basically, the green line is if you exercise with a good diet, you get a peak of oxidative stress, but it drops. It doesn't go into the antioxidative stress area, and you maintain within the normal band. If you take vitamin A and vitamin E, you get this blue line, which is an exaggerated oxidative stress, and then you get antioxidative stress as well. Other risks, testosterone. People say you shouldn't exercise if you've got prostate cancer. Complete rubbish. Testosterone levels go up for about 20 minutes and then they reduce. In fact, in the long term, most athletes are actually plagued with low testosterone levels. When to start? This is an initiative which we're involved in by the Royal College of Anaesthetists, which is trying to put people into an exercise prehabilitation program before chemotherapy, before their biologicals, and before surgery, because there's lots of data now to show it will reduce your hospital times, it will reduce your readmission times, and you'll get less things like thromboembolism. And there might be a anti-cancer benefit for that, because it changes the milieu of your body. So when it's been manipulated, it's all the body's arm to fight it. I'll rattle through these. Going on to androgen therapies, again, should be considered. This was a study we did of patients during their radiotherapy and looked at their late side effects from radiotherapy, and exercise, amongst all the other lifestyle things, which was smoking, being old, or being overweight. Exercise, if you exercise, it was the strongest predictor of less long-term side effects. So places like Genesis Care in Milton Keynes, which is a private centre, now has a gym attached to their radiotherapy unit. So when people are waiting for the radiotherapy, they exercise before they go on the treatment. Unfortunately, NHS hospitals are not doing that just yet, but I'd like to see it happening. During chemotherapy, patients are often told to take it easy. This study, called the PACES study, which randomized people into a small intensive regime against a mild regime, showed the intensive regime improved all the side effects of chemo and later effects. So you should be encouraging people during chemo to exercise. I know it's difficult, but we should. Sports performance, of course, I've already mentioned that these polyphenol-rich foods can help that, and I'd love to do more work with that. This is a study we were about to start, but had to put on hold for COVID, and it's the first study which is going to look at healthy individuals and cancer patients in the same cohort. Healthy individuals to improve their sports performance, and cancer patients to improve their ability to exercise safely and without pain. And we're going to randomize a polyphenol-rich whole food supplement, a probiotic, and put them both into an exercise regime and see if we can improve outcomes. So watch this space. We are plagued with COVID at the moment, and we're very worried about our patients catching it. And as we couldn't do any other trials, we've converted our trials unit into a COVID nutritional interventions unit while we're waiting for our other trials to start. And we are particularly looking at gut health and polyphenol intake. There was lots of data from the last SARS epidemic that we know that polyphenols have very significant antiviral properties. They reduce viral attachment, penetration, proliferation, and shedding. They help gut health, as I've just said. So a lot of COVID patients have problems with profuse diarrhea and gut problems, so it can help prevent that. They regulate inflammation so that they may help with this excess inflammatory response, which is actually one of the fatal consequences of COVID, called the cytokine storm. So we know that data, there's numerous data published, and if you will Google polyphenols and COVID, there'll be hundreds of papers, and we've looked at all this evidence, but there's been very few clinical study, if not no. So we've managed to get through ethics eventually, and MHRA, a intervention study, which is looking at a series of polyphenol-rich foods, particularly the ones with antiviral properties such as chamomile, turmeric, aloe vera, and in a combination with a very good slow-release capsule of lactobacillus probiotics, which is the safest version. And we're combining these against placebo and seeing whether it would reduce the impact of COVID, but particularly the post-COVID fatigue. And of course, these patients will be encouraged to exercise, and we're looking to see if it would increase their ability to exercise and get back to normal and get back into the workplace. And we've got 50 patients recruited so far. So anyone who who has COVID, who's been tested positive, who still has some symptoms, they're very welcome to join this study. It's very safe. These are just sort of whole foods. You can just email me or the trials unit and we'll send you the information. We can do all the consenting over the phone and send you all the supplements and actually do the questionnaires over the phone. So please refer to anyone you know. We need to get 150 patients and we're only on 50, which is a good thing because the number of patients coming into the hospital is dramatically reducing. So in conclusion, exercise is a must during and after cancer treatments. It will improve your outcome, improve your well-being. It shouldn't be looked at in isolation, should be looked at with targeted nutritional strategies. And again, we look forward to our relationship with you in University of Bedfordshire to take these strategies forward. Thanks for listening.
Thanks, Rob. That's fantastic. And if you were in one of our rooms right now, we'd all be giving you a massive round of applause, but everyone's on mute, so I'll clap you. But fantastic. Thank you for that overview of your research. I'm in awe of all the different projects that you're involved in and the impact that you're having to these patients and science in general, really. So thank you. That was a fantastic talk. Thank you. We're holding questions to the end just to allow the flow for our presentation. So anyone on the call who wants to ask Rob a question, if you can pop it in the chat, one of our ISPAR members of staff will pick it up and then we'll be able to ask those questions in the Q&A session. So Rob, thank you very much. I'm going to talk very briefly now about the exercise clinic. I saw one of the questions come up about how much exercise is important to support people. And we are really excited to be working with you, Rob, on the GAP4 project and, supporting people with prostate cancer and doing that tailored physical activity. But just to give everybody on the call a bit of a flavour of what the University of Bedfordshire Exercise Clinic does. This was the brainchild a few years ago of Kev Wild, and he's going to talk in a second. And about reaching out to our local community and to our local hospitals and care services and being able to support them with physical activity treatment as a behavioural medicine. And it began as a diabetes clinic working in collaboration with Diabetes UK, and it's expanded, and we now accept referrals with individuals living with obesity, with cardiovascular disease, with cancer, and mental health concerns through the Recovery College. And we're about to start a programme with people who've been bereaved and people with spinal cord injuries in due course. And the clients come onto campus, onto the Bedford campus, where we've got extensive facilities, sport halls, dance studios, gyms and so on. And the clients will follow an 8-week rolling programme. If they want to continue in the programme, they can after those 8 weeks are over. And that covers tailored exercise, health education and behaviour change sessions facilitated by our qualified exercise on referral staff and students. And this is Lucy and Charlotte taking some of our clients through. And I know some of the people who join us in the exercise clinic come to many of our BEDS talks and ISPAR conferences. So if you are on the call today, welcome. It's lovely to have you. And what do we do? What do our clients say about the exercise clinic? Well, I had a video to show you, but the quality of the video going across Zoom wasn't great. So I've just pulled out some quotes here. Clients say things like, I was very nervous that you stopped doing exercise. They, as in us at the exercise clinic, are making you feel more secure. This is the best thing that happened to me. Someone else says, I really wasn't making any improvement, but this has really kick-started it again. Weight started to come off. I just felt a lot healthier. Someone else said, if it wasn't for the tutors saying, come on, you can do a bit more, I probably wouldn't get to the end. And another says, I do notice at home that I'm sleeping a bit better. One commented to one of our trainers, my GP has said to me, your blood glucose is better than it's ever been. What have you been doing differently? And another gentleman says, I'm reaching for the chair or somebody to help me to stand, but actually I don't need it anymore. I find that I'm a lot more flexible, a lot more stronger, and I generally feel much healthier. So we will continue with our exercise clinic once it's safe from a COVID secure perspective. I'm going to hand you over to Kev, who's our senior lecturer and exercise practitioner who leads a lot of the exercise on referral work, just so that he can kind of give a bit more background. Kev, over to you.
Yeah, thanks, Angel. Yeah, the exercise clinic, it started off, we all know, like Rob said, that exercise is good for us, any exercise. And so we just started it off. And one of the biggest things I've been looking at is getting the students involved, because it's great doing lectures and it's great doing seminars, but actually working with real people with these diseases. And like Rob says, they're not coming with one issue, they're coming with many issues. And it's good to get the students involved where they're actually getting the skills to actually work with people so they can move on into the big bad world. I've got an incident. I've just had a text off one of our clients. His name's Dave. He's one of the cancer patients coming in, or was coming in until the COVID-19 kicked in. He's an ex-copper or retired copper. He's got blood cancer and he's an ex-regional or national bodybuilder. So he's well used to using the gym in the past. But cancer's taken over. He's lost his confidence, and I had a good chat with him on the Macmillan workshop day, and I got him to come in. And he stood outside the gate when I'm looking at him, going, "What are you doing?" So I went out and got him and said, "Where are you parking?" And he said, "If I hadn't to come out and got him, he would have turned away." And it was just that little bit, which in no book or anything, that to get him in. And he wants to come. He's just texted me just now to see when can he come back in again. So Rob, I'll be having a word with you because I want to see how we can get the cancer patients back in again as soon as we can with these conditions at the moment. So so that's us at the moment. And hopefully, sorry, Angel, my last thing is that we are looking at, and I read on the BBC News last night about COVID-19, and there's not enough centres to help with rehabilitation of the patients who've gone through the hospitalisation and that. And I want to have a look at that to actually bring that in as well to the exercise clinic in the near future. So there is other things that we're looking at as well.
Brilliant. Thanks, Kev. Yeah, there's so much more that can be done, and deconditioning is definitely something that's coming up quite a lot, and supporting people who've been on bed rest or shielding or just being sat home on a computer for so long. So I think there's lots more work to be done in terms of physical activity and sedentary behaviour. Kev, thanks so much for that. That was fantastic. Good to share what we're doing with everybody. Thank you. No one heard any of that. That's hilarious. Something had to go wrong, didn't it? Kev, I was just saying thanks. That was fantastic. Really good to share the stuff that we're doing with everybody, and highlighting what the exercise clinic has been involved in. It's fantastic work, and I don't think you heard me just then, but deconditioning since COVID is going to be something that's going to come up, that we need to support people.
I agree. It's something I want to get going on. Yeah.
Thanks, Kev. Sorry for me talking to myself for 2 seconds. Okay, so I'm delighted now to introduce two of our postgraduate students, Abby Bell and Kamlesh Day. Abby, I think we've got you up first. I've just made you a co-host, so you should be able to share your screen. Fantastic. And Abby's going to talk to us about reducing sedentary behaviour in cardiac rehabilitation. Over to you, Abby.
That's great. Thank you, Angel. Bear with me a second when I get my screen up. Can everybody hear me okay? Good, excellent. So I'm just going to be discussing today very quickly about my systematic review, where I've been looking at the association between cardiometabolic risk markers with cardiac function and structure. And then I'm going to talk about how it relates to sedentary behaviour in cardiac patients. So as you well know, cardiac patients often have an increased risk of cardiometabolic risk markers, so things like elevated blood pressure, increased BMI and cholesterol. And this can lead to an increased risk of cardiovascular disease, either primary or secondary. So once somebody's had a cardiac event, they're more at risk of having another one. Now, more recently, studies have also shown that there's an association between cardiometabolic risk markers with cardiac structure and function. We know that in healthy individuals, breaking up sitting time also improves these cardiac metabolic risk markers. So it could therefore be speculated that breaking up sitting time may also improve cardiac function and structure. And that takes us on to the aim of this study, which was to systematically review the literature looking at this association between the risk markers and cardiac function and structure. So just a quick go through the methodology. So we searched 4 databases with a predetermined string of search terms. This included things like systolic blood pressure, fasting blood glucose and BMI with left ventricular mass and ejection fraction. Returned 15,068 results, so quite a few results returned. And once we'd removed duplicates, we got 13,586. And then going through the additional 28 articles, we identified through hand searching the reference list of our included studies. So Dr. Dan Bailey and I screened these articles against the eligibility criteria, where studies had to report at least an association with at least one cardiometabolic risk marker with one measure of cardiac function and structure and be an observational study. So this left us with 233 full text articles, which we needed to assess for eligibility. And 216 of them were excluded for the different reasons you can see on the screen, such as ineligible population and ineligible study design. And that gave us 17 articles included within our review. So that takes us on to our preliminary findings. Overall, we had 6,161 participants included within all of the studies, and the age ranges between 24 and 81 years, sample sizes ranging between 50 and 2,000 participants within the studies. Participants were either healthy, hypertensive, postmenopausal, or had metabolic syndrome, and they were recruited either from a country registry or acutely during a hospital admission. And 9 cardiometabolic risk markers were reported overall. So this included blood pressure, lipid profile, so cholesterol, triglycerides, and so on, fasting blood glucose, BMI, and waist circumference. EA ratio, which is the function of the heart during its filling phase, was the only measure of cardiac function reported, and left ventricular mass, which is the standardized measure for heart size for the heart function, cardiac function. So preliminary findings, as you can see here, would suggest that there is some association between cardiometabolic risk markers and cardiac function and structure, but I'd just like to highlight these are preliminary. So 6 out of 10 studies reported a significant association for BMI with left ventricular mass index, and 5 out of studies reported significant association for systolic blood pressure with EA ratio. So promising findings. So these findings would suggest that if we do break up sitting time, as we know, breaking up improves cardiometabolic risk markers by breaking up our sitting time. So it could then improve our cardiac function and structure and reduce the risk of a further cardiovascular event. And that takes me on to my research of what I'm doing now. That summarises my study. Thank you for listening. And if you've got any questions, pop them in the chat or email me there.
Abby, fantastic. That was brilliant. Well done. And again, just highlights the importance of that kind of physical activity, sedentary behaviour breakup on our cardiometabolic health. So thank you very much. I'm now going to hand over to Kamalesh. Kamalesh, I wonder if you could share your screen. And if anyone has any questions for Abby, please do pop them in the chat, and Abby will either pick them up in the chat or we'll do it at the Q&A session. Brilliant. Over to you, Kamalesh. So Kamalesh is one of our other PhD, another PhD candidate. Over to you.
Good afternoon, everyone. Today I'm going to talk about one of my PhD study. That's the study title is Effect of Breaking Up Prolonged Sitting on Postprandial Cardiometabolic Disease Risk Markers in Overweight and Obese South Asians. Let me talk about a bit background. South Asians are at high risk of cardiometabolic disease risk compared to any other ethnic group in the UK. And based on the previous findings, postprandial glycemia and triglycerides are associated with developing cardiometabolic disease in any population. Only one study has examined the effect of breaking up prolonged sitting in South Asians. And they got findings based on the light intensity walking for 5 minutes every half an hour can improve postprandial insulin in older adult. However, the effect of breaking up sitting time with light intensity walking on cardiometabolic disease risk markers in overweight and obese South Asians are unknown. This study will establish whether breaking up sitting with light intensity walking can reduce postprandial cardiometabolic disease risk markers in overweight or obese South Asians. This is the study design. This study was a two-condition randomized crossover trial for 5 hours condition. There is a two condition. One was interrupting sitting condition, and another was just a prolonged sitting condition. Participants sat down for 5 hours long. 19 overweight and obese South Asian took part in this trial. We can see from the graph, from the symmetric diagram, there's a 2 meal were provided. Breakfast was provided on 0 hour, and lunch was provided at hour 3. Altogether, 10 blood samples were collected to analyze the blood glucose and triglycerides, and 11 times the blood pressure was measured, and expired air sample was collected for 11 times, and the participant took altogether 9 breaks for 5 minutes every half an hour. So overall, all the participants took from 45 minutes exercise in 5 hours condition. Let's share the findings. We can see from the graph, there was a trend of reduction of postprandial glycemia in interactive sitting condition. However, there was no significant difference observed in triglyceride, fat, and carbohydrate oxidation, and mean arterial pressure and heart rate between two conditions. But very interestingly, there was a resting energy expenditure significantly increased in interacting sitting condition compared to sitting condition. Let's summarize this study. Breaking up sitting with 5 minutes exercise every half an hour may acutely improve postprandial glycemia in overweight and obese South Asians. This intervention could play a crucial part to improve cardiometabolic health in this community. Further research need to be done to investigate the effectiveness of different intensity, duration, and frequency of physical activity breaks to reduce prolonged sitting in South Asian population. Thank you. So, any questions?
Fantastic. Kamalesh, thank you very much. And again, if anyone's got questions for Kamalesh, if they can pop them in the chat and we'll hold them over until the Q&A session. But Kamalesh, fantastic presentation. Well done. And again, if we were in the gateway right now, you'd be hearing a big round of applause. But, you know, everyone's on mute, so I'm sure they're clapping in their living rooms. Fantastic, well done, Kamalesh. And you know, you and Abby are now moving on to Marsha. Marsha, if you want to get your screen up ready, that'd be great. You know, really highlights the importance of not just being physically active, but also about breaking up sedentary time and you know, not sitting for too long. So you know, we say again, if anyone watching wants to kind of stand up and sit down again, then there's research that we're presenting here that really shows that's a benefit. Kamalesh, thank you very much, fantastic. And Marsha, I'm now going to hand over to you. Marsha is one of our other PhD students who is going to talk to us about the ARREST study and preliminary efficacy in police staff. So Marsha, over to you.
Hi, I'm Marsha, and I'm going to be talking about the ARREST study, which was the third study in my PhD. You've heard already a little bit about sedentary behavior, but just to give you a bit of a background in what I research, I look at sedentary behavior in the workplace, and workplace sitting time accounts for a large proportion of total daily sedentary time in office workers. Now, this is a problem because it increases the risk for some of those chronic diseases that Kamalesh mentioned, cardiovascular disease, type 2 diabetes, and even all-cause mortality. The good news is that there have been interventions which show promise not only for reducing sedentary time, but for improving cardiometabolic risk markers, which, as Abby stated, you know, these are the biological signs in the body that give an indication of your risk for developing those chronic diseases, things like blood lipids, glucose, blood pressure, etc. Now, recently, tailored behavior change interventions have come about using the behavior change wheel And they've shown sitting reductions in office workers of up to 110 minutes. That's nearly 2 hours of your 8-hour workday. And we know from those studies and from other studies in the past that for maximum efficacy, interventions need to be tailored to the target behavior. So in this case, sedentary behavior, or operationalized in the workplace, that would be sitting time, the setting and the population, because what motivates someone to sit less in one context may not work in another. There may be specific barriers, etc. So although we've seen changes in other office settings, it doesn't account for maybe these other occupational subgroups that are out there. And so what I did is I went and I worked with the Bedfordshire Police to develop an intervention for them. And office roles account for a large proportion of the police workforce. So up to, 30% at least are office-based roles. You know, you think of the cop on the beat, but actually a lot of that is happening behind the scenes in call centers, in research, database management, etc. So very few studies have examined reducing occupational sitting time in this population. So the aim of this study was to assess the feasibility of conducting this type of intervention in police staff. And here I'm going to be presenting the preliminary efficacy results of that study. So our objectives were to assess changes in sedentary behavior, cardiometabolic risk markers, and then we looked at psychological well-being and mood as well. So ARREST stands for Activity to Reduce Excessive Sitting Time. We had 24 police staff take part in this intervention. They were asked to take a 3-minute break every 30 minutes at work for 8 weeks. And what they did to enable this and to help them break up their sitting time, we placed QR codes around the building. There were 24. This was a single site intervention just at police headquarters. And participants would get up, they would scan a QR code, and it would log their break. Now, there was a team-based competition around this. We also had technological supports to help participants, apps, self-monitoring devices, alarms, etc. And a lot of these behavior change techniques that were delivered were identified from previous research in my PhD, as well as other office-based interventions, and then actual programs that are out there, such as Active Hearts. So the data we collected, so it was an 8-week intervention, as I said. We collected data before and after the intervention. It was just a repeated measures, a single arm trial. We looked at activity monitoring using an active PAL, which is a little device you wear on your leg, and it can detect whether your leg's horizontal or vertical, along with an accelerometer, so it can predict with good accuracy and reliability your sitting, standing, stepping, and postural changes. We also looked at cardiometabolic risk markers, weight, body fat, waist circumference, and then we gave them a suite of psychometric surveys, such as the positive and negative affect schedule, which measures mood. We looked at well-being, we looked at stress at work, and then job performance and satisfaction. So at baseline, participants had high amounts of workplace sitting. So they sat on average for 6.5 hours a day out of an 8-hour workday. And then about 2/3 of that, nearly 4 hours, was comprised of these long sitting bouts. That's when you sit down for more than 30 minutes at a time. 54% had at least one elevated cardiometabolic risk marker. Generally, in terms of mood, they were overall, they were generally a positive group. They had average well-being scores and fairly low stress levels to start. So in terms of results, this is sitting, standing, and stepping. We had sitting time per shift, so per 8-hour workday. We had a decrease in about 18 minutes of sitting time. We also saw that standing time seemed to be the main replacement for that. So that increased by almost 16 minutes. Total time sitting in those prolonged bouts decreased by just over an hour. So again, if you were sitting originally accumulating 4 hours in that sitting time, that dropped to 3 hours. And the number of those sitting bouts, so that the number of times they sat down for those long periods also decreased. So they went from having about almost 5 of those a day, and that dropped down to just 4 of those a day. And then finally, the number of transitions, so that's getting up from your chair, increased by about 4 counts. So originally they were doing about 22 transitions a day, and that increased to about 26. These results are very similar to another study, which was a low-cost intervention done in at a construction company, but in their headquarters, their offices, where they also found a similar amount of sitting time reduction. The only difference was their study had a walking competition, and so their sitting time was mainly replaced by stepping, and we didn't see any changes for that here. I will point out also that in terms of cardiometabolic risk markers, we didn't see any change apart from weight, which decreased almost by 1 kilogram. And in terms of the psychometrics that we measured, we did see an increase in positive affect, and that scale ran from about 10 to 50, and they increased their score by about 4 points. So in conclusion, from this study, from the preliminary effects, reducing and breaking up workplace sitting time does show preliminary efficacy in police staff. Now, we know from earlier research that cardiometabolic risk marker results are inconsistent in these kinds of studies. In this particular study, it may be that it was only 8 weeks long, so it may be that a longer duration is necessary to elicit those cardiometabolic risk marker changes. As you heard from the keynote speaker, this is a long-term commitment. It's not a quick fix. So we have seen studies of 12 months where we saw a decrease in weight, waist circumference, and insulin. Also larger sample sizes. This was a feasibility study, so we only had 24 participants. So clearly, potentially to see more changes in those cardiometabolic risk markers, you're going to need a larger sample size. And we've seen waist circumference be reduced in those larger studies. Finally, this was not a randomized controlled trial. Having that would allow us to be more certain that these type of effects are, genuine. Cluster randomized controlled trials have shown reductions in body fat, for example, after 3 months. So employing something like that in the future would help to determine sustainability and potential health impacts. But overall, this adds to the evidence showing that multi-component behavior change wheel interventions are effective across a range of office settings, as long as they're tailored with the target behavior, the setting, and the population. And furthermore, a lot of the studies that have been conducted in the past have used very expensive equipment, stand desks, cycle desks, cushions that you sit on and they vibrate, whereas our study was very low cost, very pragmatic, and easily applicable to many different settings. So hopefully this adds to the research on that. Thank you. And any questions?
Fantastic, Marsha, well done, congratulations. That was a great talk, thank you. And again, if we were in the Gateway right now, you'd be hearing a lovely round of applause. But just imagine people are clapping from their living room. But yeah, thank you for that fantastic talk. That's a kind of nice ending to this session, really highlighting the importance of not just physical activity for our cardiometabolic health, but also, that sedentary behaviour stuff. So I can see some of the questions have been answered already in the chat. We'll take maybe just 1 or 2, and then we'll have a short break before we come back, because we're running a tiny bit over. But I see, Kev, you've got a question there for Rob. I don't know if you wanted to unmute and ask.
You caught me there. You caught me there.
Caught
yeah, Rob. Is he there, Rob?
Yeah, I'm there.
Rob, I just couldn't see you there. Yeah, Rob, with the exercise, we're going to work with this GAP4 trials, but with the conditions at the moment with the virus, and you say with the actual safety, do you think it's right to be exercising those with the cancer patients with the government guidelines, or do you think it's too risky at the moment?
No, I don't think it's risky at all, to be honest, because you've got to weigh out the risks and benefits. Exercise has such a great role in improving their well-being and reducing other risk factors for COVID, such as improving the muscle to fat ratio. So as long as you take reasonable precautions, I don't know if you're able to distance. But the reality is we've got to move forward. This trial won't restart until we're allowed to restart, which is probably not for a couple of months. And hopefully the incidence of COVID will continue to be very low, which it is at the moment. And certainly death rates are very low in Bedford, even though the incidence is going up because of increased screening. So yeah, I think the answer is yes.
Thanks, Rob.
Brilliant. Thanks, Kev. Thanks, Rob. Fantastic. Thank you. There's another question. I think Abby Bell, you may have answered Abby Saunders' question. But Ben, you had a question for Marsha. Did you want to ask? Not sure if you can.
One on the chat.
Yeah. Marsha, maybe I'll ask it. I'm not sure whether Ben is able to unmute. Ben, it's nice to have you on. Marsha, he's asked, based on the QR codes, did participants just take the easiest option and visited the closest QR code each time? Did they go further?
Yeah, so can you hear me?
Yeah.
Yeah, so interestingly, so I had a map of where the QR codes were, so it was able to see where people were going. And we also conducted some exit interviews to find out how people were using the QR codes. So from that combined sort of data, basically people were they were standing up within the office and going to their nearest one, is how they broke up their sitting time.
Brilliant. Thank you, Marsha. Fantastic. And there was a question earlier, much earlier, about something around exercise programs. So supervised exercise programs. Kev, this might be one for you or for one for our exercise on referral people. So supervised exercise programs, how long would they be? What intensity? Any other note of exercise level? So don't know if that's something maybe Rob or Kev want to come in on, or Marsha even.
Well, Kev, go for this. The way I look at it with the exercise clinic is that I want them to be coming in, keep coming back in. So I like to let them do what they want to do up to a certain extent, with a bit of encouragement to do a bit more. My philosophy is do a little bit more than what you're used to. And like Rob said, start off gradual. And a lot of the ones I'm working with are the ones who have not exercised properly in the past. And we've got to start off gradually. But I'm trying to get them so they don't get the effects of delayed onset of muscle soreness, and they want to come back and make it enjoyable. But then as we go along, then increase the intensity as we go along.
Brilliant. Thanks, Kev. We don't know what happens with Rob's
my question was for Rob.
For Rob, okay, brilliant. So
yeah,
Rob,
so he proved a lot of from his research results. He proved a lot of stuff. So I want to know what was his intensity level, what kind of supervised exercise did he use? So that was for Rob, please.
Yeah.
Over to you, Rob.
I mean, the data suggests you should be aiming for about 3 hours of moderate intensity. But of course, it depends what you're trying to achieve. If they've got osteoporosis, they should be doing more weight-bearing exercises. If they're overweight, exercises to reduce fat. So it's not, it's fair enough referring to the trials, but it's actually, I think Kev's exactly right. When you've got an individual in front of you, you just want to try and get him to do as much as possible. And unfortunately, in our patients, we did a survey a couple of years ago, only 4% of men who'd had radiotherapy for prostate cancer did any form of exercise. So 96% really need encouragement. So you can't say to them, well, look, the data suggests you should be doing, you should be on a treadmill for half an hour every other day, because they're just not going to do it. So, but Kev's right, do what they can, but try to streamline it based on their individual problems. If diabetes is a risk, I particularly like them to sort of consider exercising, if it's only type 2 diabetes, on an empty stomach to try and improve, and that's been shown to improve insulin sensitivity, etc. But I mean, that's for the next phase of the program, really. The first phase is just to get people moving.
Brilliant, Rob. Thanks so much, and thanks for asking that question. Okay, we'll take a short break. We'll just take.
I have a quick question for Marsha.
Oh, okay.
what's your advice for the people like us researching and teaching and stay in our office for a long time, like sometimes 11, 12 hours a day? So what's your tips for us?
Yeah, so I mean, clearly the longer you sit for, the increased risk. So I would say limit sitting time. Laboratory studies have broken up sitting time between 20 and 30 minutes. And so if you're able to, and seen improvements in cardiometabolic risk markers. So if you're able to break up your sitting time that way, that's probably beneficial. And or replacing some of your sitting time with either standing or stepping. So you could have walking meetings. I saw someone on Twitter from the university having walking meetings this week. So it's about replacing, reducing, and breaking up your sitting time.
Can I ask a quick question?
Mm-hmm.
Of course.
I gave a talk in the Canary Wharf last year, and they've got lots of money. So they were buying everyone a standing desk, which is pretty expensive. I mean, these are several £1,000s, and there's thousands of people working in these offices. So your program suggests that probably you don't need to do that, as long as you just get up every 30 minutes, and you'd be saving a hell of a lot of money for organizations. Would you agree?
I would stress these are preliminary effects. And again, this is only 24 participants. So a larger study would need to be done. And we're sort of working towards that goal at the moment, looking to get funding for that. But I think it's an interesting alternative. And I think with things like standing desks, et cetera, it's like any behavior, you have to support it with behavior change techniques that are shown to have efficacy and that support the behavior. So if you want people to stand at their desk, you need to support that with other behavior change techniques.
Thanks.
Brilliant. Thank you very much, everybody. Cool, we could continue chatting for ages, but I feel like we need to stand. So let's take a quick 5-minute break and then let's regroup to introduce our next speaker, Emma Wells. So let's come back at about 15-16 minutes past the hour. Emma, do you want to get your slides up ready? Thanks.
Can you see them, Angel? Perfect.
Yeah, they're great. Okay. The only thing about everyone being on mute and everyone being off video is you don't actually know if they're still there. But let's make the assumption that people have gone and been able to come back. We've kind of had the allocated 5 minutes. So
I'm here, just so you know.
as long as you're here, Julia, that's all that matters. I'm kidding. Yeah, hopefully people have at least stood up and moved around a little bit, particularly after listening to Rob, Kev, Marsha, Abby and Kamalesh. So welcome back to this second half. I'm delighted to introduce Emma Wells, who is one of our former graduates from the University of Bedfordshire and who's now based at the MRC Epidemiology Unit at the University of Cambridge. And Emma's going to talk to us about physical activity trials to enhance behaviour, weight management and glycemic control, and overcoming challenges during COVID-19. So Emma, over to you.
Thanks very much, Angel, and thank you very much for the invitation to present today. So as Angel said, I'm working currently at the MRC Epidemiology Unit and have been since I graduated from the University of Bedfordshire. And today I'm going to present to you two studies, one of which the results from the first study that I worked on at the unit, and then introduce my current study and discuss the barriers we've faced because of the current pandemic and how we're hoping to overcome these to get the study restarted. So the first study I'm going to present on is the GoActive trial. This is a randomised control trial assessing the effectiveness of a school-based physical activity promotion intervention. It's going to be a very brief overview because it was such an in-depth study, but so I'll just present the primary outcome results, but there is a wealth of other information and data available, so I can point you all in the direction of that if any of you are interested as well. So by means of a background for the study, I guess it's important to understand the scale of the problem. So these figures outline the percentage of adolescents that fail to meet the current recommended guidelines of moderate to vigorous physical activity globally. And it's estimated that there's approximately 80% of adolescents that do not meet these, and there's not much sign of this improving currently. So that's why you'll see a lot of interventions and research are currently focused and targeted at this adolescence age group, because there is research that if you're active as an adolescent, you're more likely to stay that way through into adulthood as well. So the GoActive intervention is one of those interventions that try to target this age group. It's a 12-week intervention that was feasibility tested and is primarily based on these 6 themes that are on the screen now. The intention was for older adolescents and in-class peer leaders to lead the intervention to reduce the burden on the school and teachers. And the main idea was to encourage classes and students to try new activities that they wouldn't normally do part of the core curriculum. And by trying these activities, they would get points individually and as classes, and they would then be entered into competitions to win prizes. So how did we evaluate this intervention? So the study flow is outlined in this figure here. And the full Year 9 group was invited from 16 schools. So that was 8 across Cambridgeshire and 8 across Essex. And at baseline, which is the T1 in the study flowchart, we recruited 2,862 Year 9 students. Following the baseline measures, schools were then cluster randomised into either the intervention or the control arm. And this was stratified by location, so the county that they were in, and also by socio-economic status as well. Students in both both arms of the trial were then followed up at 3 further time points, which are outlined as T2, T3 and T4. And each of these measurement sessions, students would have measurements such as height, weight, fat percentage and questionnaire data collected from them. And they would also be fitted with a wrist-worn accelerometer, which is the study's primary outcome for the measure for moderate to vigorous activity. So in terms of results for the study, this is just one of the many graphs that we have, but 76% of the participants consented onto the study provided a moderate to vigorous physical activity for the primary outcome. There were no significant differences found between the intervention and the control arms. And as you can see from the figure, there was actually a decrease in overall MVPA for the whole week for all the GoActive participants. So interestingly, physical activity across both groups actually decreased by 10 minutes a day over the 2 school years that we were working with these students. So that is in support and reflective of the population level decline that is currently seen in the physical activity in this age group. So to summarise for the GoActive study then, the study does provide evidence that a school-based intervention was not effective in countering the age-related decline in adolescent physical activity levels, and does support the previous evidence and recently published work that current research based in school settings for interventions are not usually effective. However, just to add, there was an extensive process evaluation study and a lot of work that went into that was ran alongside the full RCT. That's not yet published, but it did show that a lot of the interventions were not actually implemented as they were designed to be by the schools, just because of different levels of engagement, staff availability, and numerous different factors. The initial findings in the data also show that there are some differences between the gender and SES status, and they're going to be looked into further over the coming sort of months. So that was GoActive. I'm now going to move on to the GLOW study, which is the current study that I'm coordinating at the unit. This is also a randomised control trial, and this study assesses the effectiveness of 2 different interventions for newly diagnosed patients with type 2 diabetes. It is quite different to the GoActive trial, so apologies for the swift change of context, but always just pop a question in, or you can email me as well. So this study has been directly impacted by COVID-19, as many research studies have been. So I'm just going to outline the study as a whole, identify all the barriers that we've faced, and then how we're planning to restart in some sort of format and how we're going to overcome these challenges. Again, this is going to be quite a brief intervention, but I am happy to answer questions if you have any. So in terms of background for GLOW, it is well known and well reported that overweight and obesity is the primary risk factor for type 2 diabetes. And studies have shown that a weight loss achieved either through surgery or bariatric surgery or low-calorie diet can help improve outcomes in this patient group, and in some cases actually they go on to achieve remission as well. So although they're successful, they're not scalable and they're not cost effective at all. So we're interested in looking for more scalable, maintainable and cost effective options for this specific patient group. So the 2 interventions that the GLOW study evaluate are Desmond and Live Well with Diabetes. Desmond is the standard care option that is normally offered and referred to for patients who have just received their diagnosis. It's a group-based session normally and consists of structured diabetes education being delivered by an educator to the patients. The second intervention is Live Well with Diabetes, as I say. This is a new intervention. It's not widely available at the minute, so the GLOW study is evaluating it before it is ready. This is commissioned through Weight Watchers, and it combines the same level of diabetes as a patient would receive as part of Desmond, but it also allows them to have weekly membership to Weight Watchers sessions, so it just adds in that weight management aspect as well. So patients recruited onto the GLOW study will receive either one of these when they're randomised after their baseline visit. So in terms of participant and practice recruitment, we need a total of 576 participants for the study. I think we were on about 380 before we had to pause. The participants would have received a new diagnosis of type 2 diabetes and have not yet engaged in any form of diabetes education at all. So the participants get recruited through their GP practice. We started off with about 30 GP practices and then realised we wasn't going to get the numbers we needed. So we've since increased and we're up to 140 GP practices now, and they're all recruited through these 6 CRN regions that I've listed on the screen. And we're hoping now that we've got a wider variety of regions, we're also going to get a greater mix of SES and ethnicity in the study sample as well. So like I say, the study has been paused since mid-March because of the pandemic. So we haven't been able to recruit any participants, and we also haven't been able to do any follow-up visits. But just for context, I just thought I'd outline what the study process would normally be. So participants would attend their GP practice or one of our research centres for the following measurements. They'll do this 3 times: baseline, a 6-month follow-up visit, which would normally come in just after they finish their intervention, and then a 12-month visit as well. And the primary outcome for this study is their change in HbA1c that is normally measured via obtaining a blood sample. So although we have had to pause the study to recruitment and all clinic face-to-face visits, we're working to optimise on the processes that we already had in place so that we could continue some level of data collection throughout the pandemic for those patients that would do their 6 or 12-month follow-up. So we've been sending out questionnaire packs and links for them to complete these online or on paper. We've also been asking the GP practices to continue filling out the notes reviews that they would normally do as part of the usual clinic visits. And we've also started to send back out these the risk-borne activity monitors that you saw earlier in the Go Active study to get their physical activity measures as well, because I've been able to come back into the office 1 day a week, so that's allowed those processes to be reset up. So in terms of future plans for the study, we were keen to implement something that was going to allow us to collect a HbA1c sample whilst usual clinic visits aren't happening, and also patients might not be going in for their usual diabetic reviews as well. So we're in the process of setting up this kit that allows us to post out to patients a finger prick sampling kit, so they can complete that themselves, post it back to us for analysis, and we can then provide them with their current HbA1c and also provide their GP with that result as well. It's also likely that in the time that we want to restart, patients aren't going to be able to attend their clinic for their baseline visits. So we're looking at a way of recruiting patients remotely, and that's likely going to involve the use of e-consent forms rather than paper face-to-face consent. And then patients recruited in this way would then follow the same processes that we've been using for our follow-up patients with all the remote questionnaires and then hopefully the finger prick blood kits as well. It's also important just to mention that the interventions themselves, the format of these has changed over the pandemic. So the Desmond that would normally be delivered in a group-based setting is now online only. The Live Well with Diabetes hasn't changed massively because a lot of that was delivered remotely, one-to-one on the phone or on video chats anyway. But the biggest change there would be the patient's access to the weekly Weight Watchers sessions. So I think they are either just in a Zoom like group-based setting like this, or they can just drop into their local meeting and have their weight taken, but they don't get the group support as they normally would. And obviously, hopefully, eventually, we will be back in a place where we can reinstate clinic visits fully. But obviously, we're cautious to not do that until it's fully safe and viable to do so. So for now, I think it's just a lesson for us all in learning how to adapt and utilise the resources that we've already got available to us, learning new things about new resources we didn't even know were a possibility, until the data collection can restart as per protocol. And that's me. Thank you.
Fantastic, thank you. Again, if you could hear it, huge round of applause. Oh, I can see Marsha's even put a picture up there. Emma, thank you. That was a fantastic overview of your work, and great to see you kind of flying out there in, the MRC epidemiology unit, and it's really interesting, that issue of fidelity, you know, making sure that the intervention's delivered effectively, and it is a really important one to highlight there. It's not necessarily that it didn't work, it just wasn't delivered properly, and also the issue of, you know, trying to collect lab-based data, you know, in a COVID environment at the moment. I think you're not alone there. There's probably many researchers listening in at the moment who are sharing your pain of how do you get finger prick tests, how do you get weight measurements that are objectively measured on calibrated scales and so on. So really good to kind of hear how you're overcoming some of those. Thank you. Brilliant, Emma, thank you so much. I'm now going to hand over to Julia Frewer, who's one of our senior lecturers at the university, who's going to talk about breakfast consumption, physical activity and glycemic control in adolescent girls. Over to you, Julia.
Great, thank you, Angel. And I won't read out the title again, but essentially something I wanted to point out was I'm really presenting today on behalf of our students who have done an excellent job on completing data collection for a series of studies in this area. In particular, Victoria Marari and Rachel Champion for the glycemic control research, and Claire Seal and Emma Wells, if you just heard from her, for the physical activity related research. Okay, so I think it's fair to say that the relationship between breakfast and health has received much media attention over the years, with some media reports claiming that breakfast is the most important meal of the day, whilst others have questioned this relationship, and others have claimed that it's no longer the most important meal of the day. So a potential reason, or one of the main reasons for this confusion, is because the research to date hasn't been designed adequately. So what does the research say? Well, we know that infrequent breakfast consumption is associated with increased risk of cardiometabolic disease and mortality risk in adults, and also with increased cardiometabolic disease risk markers in children and adolescents. However, as this evidence base is mainly cross-sectional, we can't determine cause and effect. There have been a small number of randomised controlled trials and crossover trials completed in adults, and these suggest that of all the health outcomes analysed, breakfast may increase physical activity, energy expenditure, and also reduce glucose and insulin responses to subsequent meals consumed throughout the day when compared with breakfast emission. And it's these acute responses that, if repeated habitually on a daily basis, that might actually lead to long-term health improvements with breakfast consumption. However, this experimental evidence hasn't necessarily targeted the most relevant populations. We know that there's typically a decline in physical activity levels and breakfast frequency in the transition from childhood to adolescence, particularly in girls. And we also know that it's important to target younger populations for prevention reasons. Something that's also often overlooked is that children and adolescents have distinct hormonal, metabolic and behavioural profiles, which mean that it's not possible to simply transfer findings from adults and apply them to adolescents. So for these reasons, we have and are currently conducting a series of crossover trials to determine the causal links between breakfast with physical activity and glycemic control in adolescent girls specifically. So one of our first studies was a 7-day crossover trial where adolescent girls consumed a standardised breakfast daily, or they consume this breakfast intermittently. So in the daily breakfast consumption condition, obviously this was over 10 days, it was a set breakfast on each day that the girls consumed. For intermittent breakfast consumption, they omitted breakfast on days 1, 3, 5 and 7, and they only consumed that breakfast on days 2, 4 and 6. The findings showed that daily breakfast consumption resulted in higher levels of light physical activity by about 20 minutes per day when compared with intermittent breakfast consumption, and also reduced sedentary time, particularly in the after school period. But these differences between the trials weren't sufficient to affect physical activity energy expenditure. So we found some interesting findings here, and we thought, well, what if we in essence take the intermittent breakfast consumption condition and replace that with 7 days of continuous breakfast omission? Would we actually see more pronounced differences? So that's what we've done in our most recent study in this area. So our key differences in study design was this continuous breakfast omission condition. We also recruited girls who habitually skipped breakfast, partly for ethical reasons. And we measured some additional outcome variables, including dietary intakes. So in contrast to previous findings, the results actually indicated that total physical activity energy expenditure was higher during the breakfast omission condition compared with the breakfast consumption condition. And I've been scratching my head as to potential explanations for this finding. You can see here this figure shows the individual responses for each participant, and it is noticeable that one girl had quite a large response in the unexpected direction, which would have contributed to the overall effect. But not only this, it was interesting that the only physical activity intensity to differ between the conditions was vigorous physical activity. And we know that this intensity is often planned and structured and might not be sensitive to the effects of breakfast manipulation. So it would be more likely to perhaps be affected by a sports club or the school timetable with a particularly active PE lesson. And it's possible that just by chance during the breakfast omission condition, that the girls had some particularly active lessons or sports clubs. Another important point is that these girls were habitual breakfast skippers. They were accustomed to the effects of skipping breakfast, so potentially the breakfast omission condition didn't have an adverse effect on them for those reasons if they'd adapted metabolically and behaviourally. Also, they had quite high perceptions of tiredness and low energy levels in the morning, so perhaps consuming breakfast wasn't sufficient to override those levels of tiredness in the morning. But moving on, our dietary intake analysis actually showed that total energy intake was almost identical between the two trials, despite the girls obviously consuming breakfast on another trial. And that indicates that when the girls did not consume breakfast, they consumed more calories afterwards, and that was primarily in the form of carbohydrate. Overall, their fibre intakes were also lower during breakfast omission as well. So it's possible that diet quality was compromised during this condition. Another possibility is that aside from physical activity and dietary intakes, other health outcomes might be more sensitive to breakfast manipulation and might be more important in explaining the links with health in the longer term. So that moves me on to the final study I'm going to talk about, which examined the second meal effect in adolescent girls for the first time. This effect has been looked into in adults, and it essentially describes how breakfast consumption can reduce the glycemic and insulinemic responses to subsequent meals consumed throughout the day. This study was completed by Victoria Marari and Rachel Champion, two of my research students shown on this slide. They recruited adolescent girls to our labs, and the girls either consumed breakfast one morning or didn't the other. So we've got breakfast omission and breakfast consumption. They then consumed a high carbohydrate, high glycemic index lunch 3 hours after breakfast consumption or omission, and they participated in a FatMax exercise test 2 hours after lunch. And throughout each trial, blood samples and expired air samples were collected. So here are the findings to date. The top figure shows the plasma glucose response for the trials, and the bottom, the plasma insulin response. And I'd just like you to focus on the second part of the graph, which is the response to the standardized lunch after the grey box there. So you can see there quite clearly that in response to breakfast omission, as shown in the white circles or white markers, glucose and insulin concentrations were exacerbated. And if repeated on a long-term basis habitually, these excursions in glucose and insulin might actually have an adverse effect on health. Not only this, we did examine some other measures. So we found differences in resting substrate oxidation rates in the expected direction. However, we didn't find a difference in maximal fat oxidation rate or fat max during the exercise bout that was completed right at the end of the trial, so 2 hours after lunch. Interestingly, physical activity enjoyment during that exercise bout was lowered in response to breakfast omission, despite the girls consuming the lunch in between. So this could have potentially an impact on subsequent motivation for physical activity, for example. So to conclude, we provided some evidence that breakfast consumption can acutely increase physical activity and also reduce glucose and insulin excursions to subsequent meals in adolescent girls. And in these studies, the girls generally consume breakfast. However, these effects might differ in girls who habitually skip breakfast, particularly the physical activity responses. So we've got a lot of considerations for future research. Specific considerations that have come out from the studies I presented, including targeting habitually inactive girls, as our previous studies often attract the more active girls, and we might be seeing a ceiling effect in these studies, and also to control for extraneous factors such as sports clubs and the school timetable. And also, finally, to directly examine whether breakfast habits have a modifying effect on these relationships. Not only this, to inform sort of an optimal definition of what constitutes the best breakfast, what should we really eat, more needs to be done in terms of the timing and composition of breakfast, and also to examine these effects across the lifespan, as we started to do in the population of adolescent girls. So finally, just to acknowledge again the students and the staff and collaborators who have really supported this research, as well as our funders. And I would like to say thank you for listening. And again, please pose your questions on the chat, or you can email me if you can find my email address.
Julia, thanks so much. Yeah, your email address is on the web. I'm sure people will find you. But yeah, if people have got questions for Julia, please do put them in the chat. Julia's our expert in nutrition and metabolism, as you can tell from that presentation. So please do get in touch if there's anything that you want to get clarified there. But Julia, again, if we were in the gateway, we'd be clapping right now. But thank you very much for your presentation. It was fantastic. So moving swiftly on over to Jane Williams now, who is a PhD student in ISPAR, again one of mine, and Jane is going to be talking to us about what roles physical activity plays in the lives of young people following the death of a parent, looking at a qualitative investigation using the TDF and COMBI. So Jane, over to you.
Thank you. I won't bother reading the title again since you've just read it. Thank you all for staying online and to listen to my talk today. As I said, I'm going to be talking about physical activity and how it can support young people after the death of a parent. So what I want to start with is actually why this research is actually needed. And it's needed because on average, it's estimated that there is 1 in 29 children who've experienced the death of a parent or a sibling, and that is 1 per classroom. Now, those numbers, that's broken down. So let's look at it as a whole. In 2016, it's estimated that 23,600 parents die each year in the UK. And that leaves behind an estimated 41,000 dependent children. Which is every 22 minutes in the UK, a child or young person will experience the death of a parent. Now, that's on your average estimated years. But however, this year, with coronavirus and COVID, and there's so many deaths, we're over 40,000 deaths within the UK alone. How many young people and children have experienced the death of a parent? We do not know yet. The research hasn't been done there. So it's something that we need to consider, and this research is so vital at this moment because we can possibly help and support those young people and children who've experienced this death. So how does physical activity come into this? Physical activity has been shown to have beneficial effects on mental health aspects, depression, anxiety, aggression, isolation, and even the quality of life. Now, we leave that to one side, we look at grief outcomes. Your common grief outcomes cover depression, anger, guilt, suicide, isolation, lowered self-esteem. So when we look at them together, there are actually a lot of similarities. So if research can support and be beneficial to mental health aspects, surely it should be beneficial to grief outcomes. However, there is not enough research to support this. In fact, there's only 5 journal articles which investigate using physical activity to support parental bereavement in young people. And these are those 5 which are just listed here. Now, those 5 research articles have used different types of physical activities, from residential weekends, which is outdoor activities, football, rugby, and then some haven't even specified which activity it is. But what they have found is beneficial. They've shown that it builds resilience in young people, that it can decrease loneliness, it helps retain memories, provides a distraction, and actually just meeting others who've experienced something similar can be beneficial in helping with their grief outcomes. But 5 journal articles isn't an awful lot. So what we have decided to do is we want to increase on that when this is where this study comes in. So the aim of this study is to find out what the role of physical activity and how it plays a part in a young person's life following the death of a parent. We want to know what are the barriers, what are the facilitators of participating in physical activity following this event, and actually to map it on to some behaviour change theories such as the COM-B and the TDF to develop an intervention which we can then use to support these young people. So to do this, we've used semi-structured interviews with 14 participants who experienced the death of a parent between the ages of 11 and 24 years old at least 5 years ago. And what we found was most of our participants were actually active and only a couple weren't active. And I just want to explain a little bit about the behaviour change theories, just in case no one is completely aware of them as of yet. So we've got the COM-B. Now the COM-B is a model which states that behaviour occurs when a person has the capability, the opportunity, and the motivation is higher to do this behaviour than anything else. So for the behaviour to occur, we need to be capable, physical and psychologically capable of doing it. We need to have the opportunity to do it. Do we have the physical and the social opportunity to do this behaviour? And are our motivations in the right place? Do we have the reflective and automatic motivation to do this behaviour? And it maps really nicely onto the theoretical domains framework, the TDF, and that helps to identify barriers, identify determinants of behaviour. It's made up of 14 domains, and as you can see from this slide, they all kind of slide quite nicely into each other. And the TDF is used when developing interventions to help with behaviour change. So these 2 theories and frameworks help to really put in a good graft when we're developing this intervention. So what did I find from my interviews? It's the most important thing I've found from this. And we find that physical activity for young people who experience death of a parent is therapeutic. It improved their physical health. It helped them find themselves. It provided an emotional outlet. It built their confidence, and they also found some social support within it. So what I'm going to do over the next few slides is I'm going to break down my 6 core themes, which are these, and into my sub-themes, and I'm going to show you some of the quotes that some of my adults have shown. So therapeutic was broken down into 3 different sub-themes. Distraction. One of our participants, Jim, said that physical activity was an escape. He forgot about everything else, and it was just a way of getting away from it all. So it provided that distraction. Got to process thoughts, allowed time to process thoughts. So Kate said there was just a peace of mind and where you were able to sort out your own thoughts. And we've also got clearing your mind. Greg said there was just something about doing physical activity that made being in your head a lot nicer, and it was kind of meditative. But physical activity also produced that emotional outlet. It helped to release that anger and frustration. So Adam said that he was never a scrapper or fighter on the rugby pitch. On that rugby pitch, it gave him that sense of release of that physical aggression that really benefited him. But it also, on the flip side, gives them enjoyment and pleasure during this turmoil time in their life, where Laura said it just lifts your spirits, and if you're feeling down, it just kind of boosts you up a little bit, essentially. And then it gave some social support. So the young people found some social support. They were able to develop friendships. So Ben stated that he joined a running club, he went to training sessions, he started making friends, and it was something that he could really get into and he really enjoyed. But there's also this aspect of social support that you don't really think about, and it's paying it forward. So a charity aspect of it. So Rebecca stated that like the charity runs, 5K charity raising runs, stated that everyone is running for the same cause, and you're trying to raise money so that it doesn't happen to someone else in the future. So you're trying to stop someone else feeling the way that you currently feel. We find that physical activity also boosts confidence. So it helped to obtain goals. So Chris stated that he found that physical activity was a sort of goal setting for him, that it was a way of forcing himself to meet certain goals and demonstrate that he was in control of himself and possibly in control of his emotions. But alternatively, it gave our young people the strength to overcome challenges. So Zara climbed Kilimanjaro, and she felt at the tough times during that climb, she pulled on the strength that the fact that she could survive, the fact that her mum had died, she could do this. So there was that mental and physical connection for her within physical activity. We also found that physical activity helped young people find themselves. So it can create a positive routine. Adam found that taking part in physical activity gave him a good structure and it allowed him to be independent and organised, which actually helped him later on in life. And then we found that just being physically active could help you become someone new or be yourself again. So Kate joined the badminton team and she found that she could relate to people on a sporting level and she felt more of herself. And then finally, we've got physical activity improving your physical health, overcoming our ill health. So Gail felt healthier and that she could breathe more. And then you've got feeling fit. It's that Ben felt he was in control, he was improving his health, and he just felt he had more control over his life and exercise. So we've took those 6 core themes and all of our sub-themes, and we mapped them onto the TDF and the COM-B. And this is what it looks like. It's a very nice thematic map. I'm quite proud of it. So we've got thematic, therapeutic, and improved physical health, which is a capability. Finding yourself, emotional outlet, and builds confidence is our motivation, and our social support is our opportunity. I'm not going to have time to go through it all, but if anyone would like to have a better look at it, let me know. And then, so what does this research actually add? So physical activity can benefit those who've experienced bereavement. It builds the resilience and it's a stronger sense of yourself. It can be used as a positive alternative to talking therapies. And bereavement organisations should take this research and previous research and provide more physical activity services to support bereavement. So where am I going with this? So this body of work is called the Baby Steps. And it is made up of 7 to 8 studies which have helped to develop the ECLIPSE intervention. And ECLIPSE stands for Everybody Connected Through Loss in Physical Activity in Sport and Exercise. And this intervention has been co-created and funded with Team Beds in Luton and Active Luton. And it's something that we're really excited to do. And in the next couple of months, we're hoping and getting to launch it so that we can actually go and support these young people who need our help. So I would especially like to thank ISPAR for funding my baby step stuff, and to Team Beds in Luton and Active Luton for helping with the ECLIPSE stuff. So thank you very much. And if you have any questions, please just put them in the chat.
Brilliant. Thank you, Jane. That was a fantastic talk. Well done. You did a great job. And, you know, this is obviously a project that's really close to my heart and, you know, something that's really important at the moment, particularly in COVID, you know, and you've gained so much insight from these young people. Yeah, it's a fantastic job. Well done, Jane. Brilliant. And it leads us really nicely into our last speaker today, who's Bert Klemmer. Bert works at CHUMS, which is a mental health and emotional wellbeing service for children and young people, who do have a bereavement service within this service. And he's going to talk to us. And I should say also one of our former graduates. Again, I'm incredibly proud of all the students who presented today, and Bert's another one. So Bert, you're going to talk about supporting young people's psychological well-being through physical activity and considerations since COVID-19. So Bert, over to you.
Thank you, Angel. Okay, can you hear me? Okay, excellent. So thank you, Angel, and everyone for presenting. It's been really interesting today. So yeah, I will be talking about how CHUMS, mental health and emotional wellbeing surveys, support young people's psychological wellbeing through physical activity, and how we had to adapt and change since COVID-19, and just the practice, how it looked like. Additionally, we'll talk about how we're supporting the Ready Trial research project, and also some of my consultancy work in Estonia with Estonian athletes and sport organizations around mental skills in sport and raising mental awareness as well. So a little bit about myself, just to show how academics and industry can work together. And this is sort of my route at the moment. So I'm working in the industry and doing some academic stuff as well. So I moved to England in 2013. Previously was a professional footballer. I played against the likes as Harry Kane, Paul Pogba many years ago, and then came to England and done my undergraduate degree and master's at University of Bedfordshire. Such a great place. And now I'm at Loughborough University, so doing my PhD there and investigating the effectiveness of structured sport and exercise interventions in enhancing the mental health of young people with mild to moderate mental health problems. And it's my third year going through the systematic review, which we're hoping to share with you all next year at ISPAR conference. And my current role as a 9 to 5 is area coordinator at CHUMS, working in Cambridge with Bedfordshire and Peterborough. And here you can see some pictures as well on that slide. So I'm looking after at CHUMS a program or intervention called Tactics Physical Activity Intervention, which is an early intervention based around CBT principles. And for those young people who are displaying challenging behaviors such as anger or managing emotions, anxiety, and how we do that is before COVID, and usually we go to schools, community venues. It's usually 4 to 6 young people per group, sometimes as well one-to-one sessions. It's a 7-week long program, so 3 one-to-one sessions and 4 face-to-face sessions. And it's usually around 45 minutes in a classroom, doing a booklet, talking about emotions, anger, and then going outside and doing physical activities such as football, basketball, or any other activities that children are interested to do. However, during COVID-19, we needed to change and adapt so we can still continue our support to those young people who need the mental health support. So we started to do all our clinical work via Microsoft Teams and phone calls, which meant the content stayed the same as when we went to the schools and community venues. However, it's all done online now, currently as well. And we're looking when we are allowed back at schools, when external visitors are allowed back at schools, we go in again. And all the physical activity sessions are done through Zoom. So every Tuesday we have a football skills session where children from Cambridgeshire, Bedfordshire come to Zoom, and we just do it all together and just keep them still active. Even though we can't do it all together in sort of real life, we can still be in that sort of online environment and share our stories, and perhaps that can help us to lift our mood as well, and they can get their activity levels that are needed as well. And of course, we recorded some PowerPoint sessions and YouTube sessions that those young people who may miss any sessions or may not want to engage with video or phone calls, that they can actually do themselves or together with their parents. Of course, it's not ideal, but it's just another way to engage and still support those young people. And of course, if there are still some young people at school now, all the children are back at school, but when sort of the first stages of COVID-19, when it sort of came, there's still some young people at school. So we called in via Teams and did a session with them from the school. And we also have a dedicated phone drop-in as well. So some learnings from COVID-19 and what we have sort of discovered is actually there's a lot of families who don't have access to internet or a computer, so they weren't able to first of all, do some of the schoolwork, but also the support with us. So we had to really adapt and think about ways, and there's some of them parents are still waiting, not only from us, but also from other mental health charities until the face-to-face delivery returns. Also, some families and young people don't feel comfortable attending the video phone call sessions. So that's the reason why we did some YouTube sessions and PowerPoint slides. And on the other side, there also has been a benefit. So we were able to reach some of the young people who usually wouldn't be able to come to the face-to-face sessions, especially when we do every week physical activity drop-in, who each client who comes to CHUMS can come in and do physical activity with us. So usually it was in Bedfordshire, but now we can have all young people from Bedfordshire, Cambridge, or Peterborough together and do them all together online. And surprisingly, what we found was that lots of more young people and parents prefer one-to-one sessions rather than group sessions during COVID-19, which as our program is usually a group session, which is a different approach we need to take. And of course, the capacity now increased as well. We usually would have around an hour and a half, 6 young people together, and now we need to fit that time in as well. So we need to thought about this as well. And here you can see the graph about tactics outcomes during COVID-19 and before. So there hasn't been a massive change. So those outcomes are around improvement in coping and improvement in goal-based outcomes. So we have quite nice and good outcomes from our interventions. So usually over 90 in improvement in coping and goal-based outcomes. So there hasn't been significant change in those outcomes. However, we can see in the coping during COVID-19 has dropped a little bit. But it's not we're not sort of worried too much about it, but we can see that has been, COVID has had some impact on young people and their families, especially around coping with mental health and emotional well-being. In terms of the READY trial project, so CHUMS is currently supporting this research team, which is led by University of Hertfordshire alongside University of Bedfordshire and other partners, which investigates if exercise is beneficial treatment for mild to moderate depression. So we are helping in recruiting young people to that research. And previously, in my previous role at Team Bats and Luton, we also helped to gather some insight around what activities young people would like to do and what are their needs and wants. And additionally, I'm going to say a little bit about my consultancy work in Estonia that I'm doing with some of the athletes there and sport organizations. So it's I founded that in January 2020, so not a long time ago. And we're working with athletes around mental skills in sport and also to raise awareness in the country about mental health, because there is still a stigma in the country, and especially around sport and of course other areas as well. And so far you can see some of the pictures, some of the athletes we have worked with. We also work with Football Association, with some football clubs, and it's not only football, so there's different sports. But yeah, that's everything. Thank you very much. And if you have any questions, let me know.
Fantastic. Again, huge round of applause. If you could hear it, it would certainly be being given to you. That was brilliant. It's great to see how you're supporting young people with their mental health and their emotional well-being and everything. So fantastic. Fantastic work. I can see that most of the questions on the chat, the speakers have been responding to them and answering them. So thanks to everyone for engaging in those and adding questions. There's one last one there for you, Bert, from Marsha around the percentage of participants achieving coping. Marsha, did you just want to expand on that question?
Oh, I was just wondering on the chart if that was a percentage of like how many
at home, perhaps the school support and also the online support that we offered, it was a bit different. So may have impacted, but we still need to research and get more insight around that, and especially during COVID as well. Because those are just two sort of outcomes that the measure. There are more, but I just thought I would sort of lay out and show those, demonstrate those.
Yeah. Thanks, just goes to show how important it is to have that kind of constant support from you guys for those young people and their families. Yeah, COVID's been challenging for many people, and as you mentioned, the lack of digital access as well. You know, you're really highlighting the additional problems there that need to be overcome, both in terms of whether people have access and also whether they want to. And we hear that a lot, that some young people just would rather not do a two-way on a video call. So thank you, thank you very much. That's fantastic. So I kind of this brings us to the end really of our session, and I'm just going to kind of leave up here some contact details for anybody who is interested in getting in touch with us. You know, hopefully you've had a really good flavour of all the amazing research that's going on in ISPAR at the moment. This is just one of our research centres for health, wellbeing and behaviour change. We have two others. Tomorrow and Friday they will be presenting on research in their areas. And I hope you can agree that today has been insightful. It's been really enjoyable to hear about all this research. It's really cutting edge. And, you know, I'll say it again, I couldn't be prouder of everybody who's both presented today and everybody who was up in the picture that I showed earlier. We've got a fantastic research centre, research institute, should I say. I just want to take a moment to thank all of our speakers. Thanks for giving your time. Thanks for bearing with us with this virtual learning and virtual conference environment. And a huge thanks to people who've been supporting behind the scenes. So in particular, our head of school and deputy director of ISPAR, Andrew Mitchell, who I know has been on the call, and Juliet Fern, who's our executive dean for the Faculty of Education and Sport, who again I know has been listening in the background. And thanks to the conference coordinating group who's brought this together, in particular Julia, who's really been helping to kind of send emails out to you all and so on, and Mike, who's been behind the scenes putting things on YouTube, and Louise and Jeff, who've been admitting people into waiting rooms and has been manning the chat to make sure that these your questions and answers have been given. So yeah, I just wanted to say a massive thank you to everybody. If you were here in the real world, I'd be taking you all to the pub now, but we'll have to wait until we can do that safely again. But thank you to everybody who has been on the call. Thanks to everyone who has been listening in. We will make this available through the ISPAR website. As I said, it's been recorded, so you can watch again, and you can follow us on Twitter to be able to find out any more updates. But I think for now, that's everything we wanted to say. Thank you for coming. Thank you for listening. Thank you to the speakers. And we hope to see you again on the Bedford campus if we're able to next year. All right, thanks everyone.